So I'm going to give you some examples here, so just write them down. Expand and simplify. And I'm just going to put down continued, right? So here it is. Negative 2t squared plus 4t minus 3 times 5t squared minus 2t plus 1. So this is a 3 by 3, right? So there's a lot more going on there. Okay. So you take the first one, distribute it among the second bracket. Then you go over to the second one, distribute that one across. Third one, you do the same thing. And then we're gonna, once we've expanded, then we collect our like terms, okay? And there's only one variable, make a note of that. Okay, so if you wanna go ahead and do this yourselves already, negative 2t squared times 5t squared. Negative 2 times 5 is negative 10. T squared and t squared end up being t, watch this, to the power of 4, right? The exponents add up when it's variables that you're multiplying, when they're like terms, right? Negative 2t squared times negative 2t, a negative and a negative turns into a positive t squared, and t is t to the power of 3. Right, so it's this all over again, right? So I'm going to try to get that in there. It just gets really messy if you have 3, right? And then negative 2t squared times 1 is just negative 2t squared, right? And then you move over to the second one here, and you go first, second. See how foil would not do a very good job here, right? If you just stuck with foil, it's like, wait a minute, first, out, inside, last, that's it. But if you stick to this method, FOIL is something that you may have heard in grade 9. I'm not sure if you heard it, but some teachers use that acronym to help you multiply. Okay, so 4t times 5t squared, that's positive 20t cubed, right? 4t times negative 2t, that's negative 8. Do the numbers first, and then your variable. 4t times 1 is just 4t, right? And I don't know, this is going to get a little messy here, but I'm going to use a different color. Okay. So negative 3 goes here, goes there, and goes there, right? So negative 3 times 5t squared, that'd be negative 15t squared, because it's only numbers here multiplying, so the t squared just tags along. Negative 3 times negative 2t, that's positive 6t. And then negative 3 times 1 is just negative 3. So it's a lot more terms that you end up with, right? So it's 3, right? 6, 9. So a 3 by 3 gives you 9 terms. A 2 by 2 gives you 4 terms. A 2 by 3 gives you 6 terms, right? You kind of look at that as a pattern because you could forget one and then it throws everything off, right? So let's collect our like terms. I'm going to scan and I'm going to look for the highest power of t, which is right here. So there's no other t to the power of 4, so we just write that one down. If you want to do a light cancel like that to help you notice, okay, I took care of that. I don't need to worry about it. T cubed, there's a T cubed here, T cubed there, and that's it. So they're both positive, so they add up to 24 T to the power of 3. And I'm just going to do a light scratch like that, so I don't need to worry about those. There's T squared, one there. There's a T squared there. And there's another T squared there. Those are like terms, right? So they're all negative, watch that. So I can add them all up and just have a negative answer, right? So 8 and 2 is negative 10, and another 25 is negative 25 T squared. And I'm going to do a light cancellation over them, or just a line over them. I took care of those, right? 4T and another 6T, they're both positive. You add them up, you end up with positive 10T. Got rid of those. And you have a constant at the end there, and it's cleaned up there. That's your final answer. And I have them in descending order, right? The exponents. And there you go. Question 2. So again, today we're doing the heavy hitters, right? Like the ones that are a bit more challenging. You may have seen them in the homework. If you couldn't do them or you were challenged by them, perhaps after this, you're going to be in better position to tackle those. Some of these may not be on the homework pages you've seen. Just going to scroll up, okay, folks? So just bear with me there so the back row can see. So those are all ends. Okay. So whenever you have a subtraction between, there's a left side of the subtract symbol and there's something on the right side, the subtraction will happen at the very end, okay? What I will do first, I will tackle the multiplication between these two brackets and these two brackets, right? That's going to be my second line, expanding those. And my next item is going to be making sure this -2 finds its way into what I get when I multiply these two. And then at the very end, I'm going to apply, right? So you're basically applying the -2 to whatever you're going to get out of this. And you're applying the -1 to whatever you're going to get out of this, okay? So, but first, always do the brackets and then worry about what's in front of them. That's the best method, proven to work every time. So I'm going to write down the -2 and I'm going to distribute. So 3n and 2n, that's 6n squared. Okay, here. 3n and 4, that's 12n. -1 times 2n is -2n. -1 times 4 is -4. Close the bracket there. And I'm just going to make a note here. So distribute brackets first before multiplying the coefficient. And the coefficient is just a fancy name for the number that's in front, standing alone, right? So you have a -2 and a -1 in front of the brackets. So then we're going to go minus, distribute this, right? That's 7n squared. That's 42n. This is 5n, right here, and then it's 30. Close brackets. And I thought about it yesterday. I kind of go every which way, it doesn't matter. But I'm going to combine my like terms first. I'm going to clean this up before I apply this out. Okay? So clean that up. So that's 6n squared. 12n minus 2n, that's just plus 10n minus 4. Subtract 7n squared. 42 and 5 is 47. Plus 30. 47n plus 30. I'm going to put a combine like terms, right? That's what happened in this line here. From the previous line, we combined like terms. And now we're going to distribute this out. So it's -12n squared, -20n, +8. And I'm going to take this negative and distribute that. Keep in mind it's -1, right? So negative, it changes the sign of every term in this bracket. So if you used to be a negative, now you are a positive. If you used to be a positive, right? They're all positive actually in that bracket. They all turned negative. Okay. I'll make a note here. The negative changes the sign of all terms in brackets. So this is important to know, right? This one here. Right, that negative right there just changes the sign of all the terms in that bracket. And now you combine like terms again, right? You don't want doubles. So I'm going to say, hey, there's a 12n squared there, and there's a n squared there. So they're both negative, so you can add them up. So that's -19n squared. I'm going to slightly just cancel them out so I don't have to worry about them anymore. If your teacher next year yells at you, should be yelling in the first place, for doing that, just don't do it anymore, okay? That's all I'm going to say. -20 and -47, they're both negative, add them up. So -67n, let's get rid of them. And then the 8 and the -30, right? That is actually -22, right? You have a bigger negative number, so that sign comes with you, and just subtract them and you get 22 left over. And there you have a nice simplified expression, and you started off with this, right? Okay, we'll try. I wanted to try to address one of these here in the homework. Did I assign 17? but I'm going to show you what this is going to make reference to. Sorry about my camera can't. Did I assign this question? Yeah? Okay. Some of you are probably like, scratch, right? Like, what's happening here? What I just showed you is basically what's going to happen here when you get a question like this. Okay? If I ask you to find the area of the shaded region, right? You're basically going to find the area of the big rectangle, which is all of it, and you're going to find the area of that small rectangle, and you're going to subtract them. Okay? You're going to subtract the big area minus the small area. So I'm going to do this with you. Okay? I'm going to do that with you. So I'm actually going to write it down. I'm going to copy it. So, but just so you know, I didn't cover that. So now here it is. So let's just make it as a part of our questions here. Okay, and we're just going to find the shaded area. Right, so this is our just a light shade here. And the side lengths are 5x plus 8 and x plus 2, 6x plus 2 on this side. So these are the side lengths there. And then you have 3x and x plus 5. This is page 187, question 17. There we go. Thank you. Okay, so how in the world would you do this, right? So area of shaded. So here you have to apply your knowledge of areas, right? Area of the shaded region would be area of large minus area of the small inside, right? And this is what you're going to go by. So they're combining your knowledge of areas and your knowledge of polynomials. Okay? Except for you're not going to get a number. It's just going to be an expression because we don't know what x is, right? So here we go. Area of shaded. So I'm just going to rewrite this in terms of this, right? So I'm going to say the area of the large for us is 6x plus 2, right, times 5x plus 8. Right? If you multiply the length and the width, you get the area. And we did that. Area of small would be 3x times x plus 5. Hold it. Does that make sense? What I'm doing? Yeah? Okay. Some of you are like, when is the bell going? I got to get out of here, right? Area of shaded, then we would have to say, hey, we're going to take this and we're going to subtract this from it. So here it is. So area of shaded now is going to be area of large, because that's what it's asking me for, 6x plus 2 times 5x plus 8 minus 3x times x plus 5. And I just did something like this with you, right? I just did it on the previous question. Because you know the answer, because it's in the textbook, right? It's there. I'm going to ask you to do this right now, because I'm pretty confident that not a lot of you gave this a shot. If you did, good for you. Okay. If you struggled and you tried it, good for you. Okay. Don't give up. Ask me the questions. Okay. So now go ahead and solve this and see what you get. You can check the textbook. And I'll be right back. Okay. One more. And this is what I want you to do after today's lesson. Okay. I'm pumping the brakes even though I normally wouldn't. I'm pumping the brakes, okay? Because the next thing we're doing is basically going to go from here, right, back to where we started. We're going to go backwards. That's called factoring, okay? So I need you to be really good at this kind of stuff. So watch out for that negative. If there's brackets, do that, but keep that in brackets. Keep your answer that you're going to, especially if you have a negative in front. This one had a positive lurking. It doesn't matter. Like you don't have to have it in brackets because that positive isn't going to do anything. A positive one isn't going to change anything, but a negative is. So you got to be very careful. Okay. Let's do the harder ones I assigned. 21C. So 187, 21C. And it goes like this. 2x minus 5 times 3x plus 4. And to make matters worse, squared. I'm doing the harder ones. Don't underestimate the easier ones, like the ones at the beginning. When you have something like this with a squared, right, you need to rewrite that. So I'm going to rewrite it as 2x minus 5 times 3x plus 4 times 3x plus 4. That's the best line of defense in my opinion. Okay, rewrite it. There's a shortcut, but I'm not gonna give you the shortcut just yet. Okay, you need to be comfortable. So there's three brackets multiplied. You pick any two you would like. You can start with these two, and then you're gonna get something out of that, and then you multiply it by the front, or you do the first two. You're gonna get something there, and then multiply by the third. It's up to you. I'm gonna multiply these two back here. And I'm going to get 3x and 3x is 9x squared. 3x and 4 is 12x, and you should recognize this one, right? Plus 12x plus 16. Clean it up one more time. It just makes it easier, more efficient if you don't have repeating terms. And after that, notice that you have the 3 in the back, the 2 in the front. You could flip them, but it really doesn't matter as long as you stick with this method, right? That's 18x cubed. That is 48x squared. And that is 32x. Right? So you take the 2x and you multiply it across the whole second bracket. Then you go negative 5 times 9, that's negative 45x squared. 5 times 24, that's a negative. Right? You get 5 times 4 is 20. 5 times 2 is 10. So that's 70x. Right? And then negative 5 times 16. That would be 6 times 5 is 30. And 5 times that's 80. Right? Negative. Right? basically turned everything, changed the sign of everything. X cubed goes first, x squared here, and here you end up with positive 3x squared. Get rid of that. Get rid of this. You have 38 left there. Negative 38x. And then minus 80. And there it is. And because there are 3 brackets multiplying and there's an x in each one of them, you are expecting an x cubed, right? Somewhere. Okay. Oh yes. Sorry guys. Yeah, there's no 70, is there? 5 times 4 is 20. 5 times 2 is 10. So yes, that's 120, right? Thank you for letting me know. Is it Friday? Because usually that only happens to me on a Friday. Oh, okay. 5 times, did I get this right? 5 times 6 is 30. 5 times 1, there we go. Okay. Yeah, thank you. So that would change things, wouldn't it? I need to change my x here. So you have negative 20 and 32. So that would give me 88, right? There we go. Anything else? Is that good? Okay. Thank you. Thank you. Thank you. Homework. Just look at the previous day. And so previous day, if you haven't done it all, plus I think I would just add more 21 type questions. So 21 A, B, C. How about we do that? To have a bit more challenging there. Did I assign 17 whole like both questions? Okay. So you can try 17, that there's the one area question still, right? The shaded. Maybe give that a try. So be proactive and